So, let's add in the marker. Today we're continuing on to chapter 12 of the Game Programming Patterns book, which I think, is it around halfway over? How many chapters are there? There's 20, so we're actually over the halfway point. And we're straight up in the, let's see, where is it? Behavioral Patterns chapter. So we did bytecode last time. We're doing Subclass Sandbox this time. Let me know if the music is a little bit too loud or not. I'm gonna try to keep it at a little bit less than half of my volume. And I'm going to, do you like the having the drop game on during like the reading time, or should I turn it off? I have a feeling it's a little bit distracting, and that's why I like have my instinct is to turn it off while I'm like going through and doing stuff, and then maybe like turning it back on during the ending times. Of course, like it's on the entire time. I'm just hiding it, so you can still play. I think you turn it off when you're not working on it. Okay, sounds good. Of course, it's still like actually there. I'm just hiding it. So if you want to play it, that's still an option. All right. So here we go. Subclass Sandbox. Intent. Define behavior in a subclass using the set of operations provided by its base class. Are links okay? You have a friend making a CPU ray tracer to learn Rust. If you happen to want to do some code review, but really no pressure, you're just chatting. Oh, let's see. I'm okay with link. I haven't like turned links off. And it's been a while since like anybody spammed any bad links that like made me want to do that. That being said, I probably wouldn't open up links on stream if they don't go to like known domains like GitHub or something. And then of course right now I wouldn't do this. You could find me on, like, if you tweet, you could like send me a message on Twitter, and then send me that, or on Discord. Although I don't have my Discord channel here. So maybe yeah, I mean, you could whisper me. All those different ways of getting in contact with me are fine. Or just leave a comment in the videos if you want me to take a look at something. And then I will look at it if the URL doesn't look dangerous to me. All right, continuing on. Define behavior in a subclass using a set of operations provided by its base class. Immediately, just on the name of this chapter, I already have suspicions that Rust is not going to do too well with this because there is no inheritance, therefore no subclassing in Rust. Motivation. Every kid has dreamed of being a superhero, but unfortunately cosmic rays are in short supply here on Earth. Games that let you pretend to be a superhero are the closest approximation. Because our game designers have never learned to say no, our superhero game aims to feature dozens, if not hundreds, of different superpowers the heroes may choose from. Our plan is that we'll have a superpower base class. Then, we'll have a derived class that implements each superpower. We'll divvy up the design doc among our team of programmers and get coding. When we're done, we'll have 100 superpower classes. When you find yourself with a lot of subclasses, like in this example, that often means a data-driven approach is better. Instead of lots of code for defining different powers, try finding a way to define that behavior in data instead. Patterns like typeObject, bytecode, and interpreter can all help. So, for example, like an ECS would be better in this case. We want to immerse our players in a world teeming with variety. Whatever power they dreamed up when they were a kid, we want in our game. That means these superpower subclasses will be able to do just about everything. Play sounds, spawn visual effects, interact with AI, create and destroy other game entities, and mess with physics. There's no corner of the codebase that they won't touch. Let's say we unleash our team and get them writing superpower classes. What's going to happen? There will be lots of redundant code. While the different powers will be widely varied, we can still expect plenty of overlap. Many of them will spawn visual effects and play sounds in the same way. Freeze ray, heat ray, and Dijon mustard ray are all pretty similar when you get down to it. If the people implementing those don't coordinate, there's going to be a lot of duplicate code and effort. Every part of the game engine will get coupled to these classes. Without knowing better, people will write code that calls into subsystems that were never meant to be tied directly into the superpower classes. If our renderer is organized into several nice, neat layers, only one of which is intended to be used by code outside of the graphics engine, we can bet that we'll end up with superpower code that pokes into every one of them. When these outside systems need to change, odds are good some random superpower code will get broken. Once we have different superpower classes coupling themselves to various and sundry parts of the game engine, it's inevitable that changes to those systems will impact the power classes. That's no fun because your graphics, audio, and UI programmers probably don't want to also have to be gameplay programmers too. It's hard to define invariants that all superpowers obey. Let's say we want to make sure that all audio played by our powers gets properly queued and prioritized. There's no easy way to do that if our 100 classes are all directly calling into the sound engine on their own. What we want is to give each of the gameplay programmers who is implementing a superpower a set of primitives they can play with. You want your power to play a sound? Here's your play sound function. You want particles? Here's spawn particles. We'll make sure these operations cover everything you need to do so that you don't need to include random headers and nose your way into the rest of the codebase. We do this by making these operations protected methods of the superpower base class. Putting them in a base class gives every power subclass direct, easy access to the methods. Making them protected, and likely non-virtual, communicates that they exist specifically to be called by subclasses. Once we have these toys to play with, we need a place to use them. For that, we'll define a Sandbox Method, an abstract protected method that subclasses must implement. Given those to implement a new kind of power, you create a new class that inherits from superpower. Override activate the Sandbox Method. Implement the body of that by calling the protected methods that superpower provides. We can fix our redundant code problem now by making those provided operations as high level as possible. When we see code that's duplicated between lots of the subclasses, we can always roll it up into superpower as a new operation that they can all use. We've addressed our coupling problem by constraining the coupling to one place. Superpower itself will end up coupled to the different game systems, but our 100 derived classes will not. Instead, they are only coupled to their base class. When one of those game systems changes, modifications to superpower may be necessary, but dozens of subclasses shouldn't have to be touched. This pattern leads to an architecture where we have a shallow but wide class hierarchy. Your inheritance chains aren't deep, but there are a lot of classes that hang off the superpower. By having a single class with a lot of direct subclasses, we have a point of leverage in our codebase. Time and love that we put into superpower can benefit a wide set of classes in the game. Lately, you find a lot of people criticizing inheritance in object-oriented languages. Inheritance is problematic. There's really no deeper coupling in a codebase than one between a base class and its subclass, but I find wide inheritance trees to be easier to work with than deep ones. So, obviously Rust doesn't have inheritance, so this is clearly going to be a problem with this. Traits could potentially be a way to do this, but what I got out of this chapter early on is that this is really a problem solved by dependency injection. If we create the functions or the classes or whatever that define what each call into the other parts of the application are, then we can inject those in. Then those subclasses don't need to go out and directly call. They're just going to call whatever is passed into them. If we need to make a change to that, especially for testing, that's easy. Just change what we pass in. And it sort of sounds a little bit like that. And Rust can do dependency injection. So that's a possibility, although it's still not going to be exactly the same as this. So I still think that more of a different pattern, like the data-driven pattern, like an ECS, would be better. The pattern. A base class defines an abstract sandbox method and several provided operations. Marking them protected makes it clear that they are for use by derived classes. Each derived sandbox subclass implements the sandbox method using the provided operations. So protected, when adding protected to a class, so let me add in a language here that, see, what language should I use that I'm familiar with that does, let's do, I don't know if, does TypeScript have that? I don't know. We could use PHP. So let's do subclass sandbox.php. Yes, I know it's not really PHP stuff. Don't worry about it. I also keep on forgetting how to like do the PHP like opening thing. But the idea is that you can still have a class. We can have a class like my I don't know, what would a superpower be? It would be like a laser vision. Something like this. Then we can have in here just like normal methods. So what are the different methods? We can do public function, like something. So this is public, something like that. We can have private functions. So private function, this is private. Then we can have static functions. So this is static. Now in static, it can also be public. So we can have public static function. This is public and static. You can have private static. Like I found that it will allow you to do that. I don't know what the point is, but you can do that. But then we have this protected. So we have protected function. This is protected. Okay, so then the idea here is that in this is public, we can call this this is private. So this is private can be called from the public function here. In static, if we want to call this, we can do it outside of here. So we can do laser vision. This is public and static. That's how we would call it at this point. And then this protected function cannot be called, like the compiler, it will error out. So even though PHP is not a compiled language, it is interpreted language, so it's going to, just in time compiled. It's going to still protect us by preventing us from being able to run this method from instantiated instances. So if I create an instance of laser vision, for example, so let's do laser vision equals new laser vision. Fun fact, in PHP, you don't need the parentheses if there's no constructor, or there's nothing in the constructor, which is always something that weirds me out. But okay, we have an instance of laser vision, at this point of time, we can now do laser vision and call some of these functions. So for example, this is public is now a function that we can call. We cannot call this is private because this is only available to inside of the class, essentially. If we want, we already have how to call the static method. If we want to call this protected method, we're going to have another class here. So let's create a class. What can derive, like what can we extend from laser vision? So maybe like blue laser vision or something. I don't know. I probably should have started with like Superpower and gone that way. Okay, so we have blue laser vision. And here we can have a public method. So we could have a public function. This is public. And in here, right, we have to extend. So extends laser vision. And now in here, I can say this is protected. So I can now call this is protected from inside of here. And I can make this private or public and or whatever. To make it so can you call it outside, from this position. But this is like the general idea of protected, private, public. The compiler will error out if I try to use these functions in the wrong way. And so it's more than just intent signaling to other programmers, it's intent signaling to the compiler itself. Okay, keep in mind, inheritance is a bad word in many programming circles these days, and one reason is that base classes tend to accrete more and more code. This pattern is particularly susceptible to that. Since subclasses go through their base class to reach the rest of the game, the base class ends up coupled to every system and any derived class needs to talk to. Of course, the subclasses are also intimately tied to their base class. That spider web of coupling makes it very hard to change the base class without breaking something. You've got the brittle base class problem. The flip side of the coin is that since most of your coupling has been pushed up to the base class, the derived classes are now much more cleanly separated from the rest of your world. Ideally, most of your behavior will be in those subclasses. That means much of your codebase is isolated and easier to maintain. Still, if you find this pattern is turning your codebase into a giant bowl of code stew, consider pulling some of the provided operations out into separate classes that the base class can dole out responsibility to. The component pattern can help here. Another way that it can help through clean code or clean architecture is something called I just had it in my brain and I just totally fizzled out. The facade pattern. So the facade pattern, if we have, let's go into our JavaScript here. So let's say we have our class Superpower. Then we have our constructor that doesn't, maybe it doesn't do anything right now. But more specifically, we have like all of these methods that now we want our derived classes to have access to, but we don't necessarily want to have them in here. What we can do is define some of these functions elsewhere. So if we have a function like display laser color, and then like source destination, something like that. if we do this, we could put this in the superpower. Now we can't necessarily just say like display laser here, because unfortunately that's not coupling it, it's creating a new one. So what we'd have to do is put this into the constructor here, where we can say this dot display laser equals a reference to display laser. Now this means that a reference is like embedded into the object instead of using prototypal inheritance. But this does mean that Superpower doesn't actually define how these are worked. We can now have these edited and worked on in different areas of the code base. And Superpower is just a facade that collects all of these together and pretends to be the one that controls them. Sample code. Because this is such a simple pattern, there isn't much to the sample code. That doesn't mean it isn't useful. The pattern is about the intent, not the complexity of its implementation. We'll start with our Superpower base class. Okay, so we have Superpower. All right, so this is the inherit, like this is not gonna do much here. Okay. The activate method is the sandbox method. Since it's virtual and abstract, subclasses must override it. This makes it clear to someone creating a power subclass where their work has to go. Unfortunately, a lot of the languages I work with, that's not something that I can do really. The other protected methods, move, play sound, and spawn particles, are the provided operations. These are what the subclasses will call in their implementation of activate. We didn't implement the provided operations in this example, but an actual game would have real code there. Those methods are where Superpower gets coupled to other systems in the game. Move may call into physics code. Play sound will talk to the audio engine, etc. Since this is all in the implementation of the base class, it keeps that coupling encapsulated within Superpower itself. Okay. Now let's get our radioactive spiders out and create a power. Here's one. Okay, so we have class Skylaunch. Okay, extend superpower. We override activate. So play sound sproing. I guess that's like the audio, like, I don't know how loud it is maybe. Spawn particles, dust, and then move 0, 0, so X, Y, and Z. So like towards the player. Okay, maybe being able to jump isn't all that super, but I'm trying to keep things basic here. I guess this is Y. This power springs the superhero into the air, playing an appropriate sound and kicking up a cloud of dust. If all of the superpowers were this simple, just a combination of sound, particle effect, and motion, then we wouldn't need this pattern at all. Instead, Superpower could have a baked-in implementation of Activate that accesses fields for the sound ID, particle type, and movement. But that only works when every power essentially works the same way, with only some differences in data. Let's elaborate on it a bit. Okay, so in the base class, Superpower, we have now we have like get hero X, get hero Y, get hero Z. Okay, so like a bunch of different get the heroes. Here we've added a couple methods to get the hero's position. Oh, okay, so let's get our own hero, not like different heroes. Like, I was thinking it's gonna get like the instance of the hero, not like this is why they're X, Y, and Z coordinates. Our Skylaunch subclass can now use those. Okay, so if gets heroes equals 0, if we're on the ground, near the ground, so do a double jump, way up in the air, so do a dive. Okay, so yeah, that makes it a little bit more interesting. Since we have access to some state, now our sandbox method can do actual interesting control flow. Here, it's still just a couple of simple if statements, but you can do anything you want by having the Sandbox method be an actual full-fledged method that contains arbitrary code. The sky's the limit. Earlier, I suggested a data-driven approach for powers. This is one reason why you may decide not to do that. If your behavior is complex and imperative, it is more difficult to define in data. Okay, so if we want to sort of like play with this, let's go and reset this and create these like classes. So JavaScript's going to be a little bit easier because it actually follows object-oriented patterns. So we can have our class Superpower. We don't need a constructor because we're not going to do anything with it here. We have this activate method, but really it's protected and it needs to be overwritten. Unfortunately, there's no such thing in there's no such thing in JavaScript. I can do tricks to try to like force people to do it. For example, I could do something like activate throw new error. This has not been implemented. This will force you to implement activate. If you don't implement it yourself and try to run it, that would ruin your day. So for example, if we now have our class, what did we call it? Sky Launch. So if we now have Sky Launch and it extends Superpower, we will need a constructor here if no other reason than to call super. We don't need to do anything with that. But now if we attempt to run activate on it, so const sky launch equals new sky launch, sky launch dot activate, this will give our program a really bad day. So we must now overwrite it and redefine it. And then we're going to have like move, play sound, spawn particles. And I guess this is, I still don't know why this is like in Superpower, because this sounds like it's like moving the player. So like we have move, X, Y, and Z. I guess like the idea is that the Superpower is causing the player to move. It's like move the player. We have play sound, sound ID, and I guess the volume. So play the sound and spawn particles. Particle type, and then count how many of them we want. Display the particles. Okay, so if we have these type of things, now what we're also adding in later on, so get hero X, get hero Y. Then like more things can go into here. So get hero X. This will get the X position of the hero. Get hero Y. Get the Y position of the hero. Get hero Z. If we're in a 3D game, get the Z position of the hero. Okay, and so then that allows us now to work on our sky launch here. Wait a second, I put these in the wrong one. These are in sky launch. Ah, okay, hold on. There we go. we prevented the disaster. Sky Launch can't move, doesn't define how to move the player anymore. Okay, so back to Sky Launch. Now in here, this is where we say like, okay, we want to play the sound of like what the sound is. So in activate for this, we're gonna this dot play sound. Maybe it's gonna be like sproing 1, assuming that like, yeah, this dot spawn particles. This will be like dust, like 200 because why not? And then this dot move. I would think that it's the Y, right? I've not really done much 3D programming, like 3D visual stuff before. Isn't it like X is on this plane, Y is like on that plane, and Z is on like the towards you plane? So wouldn't it be like Y? So I would imagine it would be something like this. Okay, and then in Sky Launch, so now we can like do a little bit more interesting stuff to figure out like what the state of the hero is. This is get hero Y. Okay, so if we figure out what our current Y is, so get hero Y. I wish there was a way for me to do like a kind of match type thing, but unfortunately it does look like I have to do a some kind of if-else statement for this. Okay, so if this dot get hero Y, if this is equal to 0, so we're standing on the ground. Standing on the ground. So then we're gonna do our sproing and just like jump into the air like normal. Else if this dot get hero Y, if this is less than, let's say 10, now we're near the ground, so in the air, but not high up. So then we want to do like a double jump apparently. But what's interesting is that we're not doing they're not having us do a spawn particles. I've actually seen a lot of like spawn particle type stuff in this too. But it wouldn't be dust now. Now it would be, oh, and this would be like swoop. Yeah. Spelling. This would now be like air cloud, like cloud. And maybe we do only 50 of them. And maybe we don't jump as high. So like maybe that's only 10, half the height of this. Oh, interesting. We have to figure out where we are. Wait, is this a destination of where we're going? I always thought it was like move it more to that. But if now we need to say, okay, we need to get the hero. So this dot get hero Y. Minus 10 more. And then finally, else. We are higher than that. So here, let's see. We are high in the air. And so now we're going to do this dive attack thing. So I'm going to copy you. So we're going to do dive. This one, maybe we don't do the spawn particles for this. And then the move, we want to this dot, like go back to 0. Move the hero back to 0. Particle sparkles. Interesting. Okay. Okay, so that's pretty much like what we have here for this. Now, if I wanted to do this in Rust, this would be a little bit difficult, right? Because we can't, there's no inheritance. So if I wanted a superpower, this sounds like it might be better to be a trait. So if I trait superpower, then I can have these methods that we would add in here. So activate is something that must be implemented. Well, in Rust, that's fine. Now that if we define this, it must be activated. It must be implemented by whoever implements superpower. So this would be function activate. This takes in mutable self because it might mutate itself. And we don't really know what it returns. Maybe it just calls other things. And so maybe that's what it is. But then there's these other methods here. It's like move, play sound, spawn particles. So function move, mute self. But now here's where it gets really interesting because we can have like the X, the Y, and the Z that's coming in. So we can have the X, which is an F32, the Y, which is an F32, and the Z, which is an F32. The thing is that this is somehow affecting the player outside of this. What are you upset about? Oh, right. Yeah. This would have to be move hero. Move is a protect, like it's an actual keyword. Okay, so if we have move hero, something like this. Well, let's say I did something like I had a mod, like all the move, all like the physics stuff. It's like the mod physics, and we were like using physics, physics or something like that. Maybe we're not like modding directly out of here. Maybe we're able to get like out of the game. It's like use the main, probably like use super, like an instance of the physics. I mean, this is a problem here because like we can't actually get access to anything to update it manually. So if we want to have some kind of like default implementation of this, what we're going to need to do is inject it in. We're going to need to take in something like the context or the hero itself. So like maybe the hero, which is a type hero. Maybe it's like a mutable reference to the hero. And then at this point, we can now manipulate, like move the hero. So what might that look like? Well, we might be able to say, okay, so we're going to say hero dot hero dot apply force, and then pass it in the X, the Y, and the Z. Like maybe this is like the force that's making them go up or down. Something like that. And then that will, this is now a default implementation. We don't have to now override it on the superpower. So now if I have our struct, what do we call it? Sky launch. We don't necessarily store anything in here, but we're now going to implement superpower for sky launch. And so it's going to yell at us right away, activate must be implemented. Okay, so function activate, which takes in a mute cell. Okay, great. We're not going to return anything because this doesn't say that we can. We must implement this, so we must do something. So we are going to launch into the sky. So that maybe we can call this superhero. So self.moveHero, and now we can pass in like the 0.0, 20.0, 0.0, and then the hero. Well, I need access to the hero now, and so this is a problem. Well, so that means activate here is going to have access to and now activate must know like that we're doing this. Now, okay, if we take that in, we get the hero, and now we can pass in the hero here. Okay, we're okay. We're still okay. This should be fine. Somewhere else where we're launching this, we're gonna have to pass in a mutable reference to hero and hope that we're not like getting two of them. Let's add in some more of these. So we have play sound and spawn particles. So function place. These are like that. Play sound. So these like don't actually sound like they need, like maybe we could just do self like that. And this is going to be the sound ID, which is like maybe like an int, an i32, and then the volume, which is maybe a like an f8, a very small f. Is there a small one? Can I do like f16? I'll just do f32 for right now. And then this one again. We're now gonna like play this sound by default. And so now we're gonna like do whatever. We have to figure out how to play this sound. Well, problem, I don't have access to like the entire sound engine thing here. So how do I get that? I either have to have like a global something that's playing the sound, or I'm gonna have to have this passed into us. So like the sound system, which is now gonna have to be a mutable reference to like the sound system. We can see where this is going, right? This is not good. So sound system dot play sound. We pass it in the sound ID and the volume. Okay, so we're happy again, but now we need the sound system here, which means we need the sound system here. Okay, so sound system mutable reference to the sound system. Well, that now means activate now needs mutable. Okay, so now we need to update it here too. So sound system mute sound system, but now we can call this this method. So self.play sound. Let's do like sound ID 3. Volume is gonna be I guess this would be like a some kind of global that we have around. So maybe this is like jump sound. Our volume could be 1.0. And then our sound system. We just pass in sound system. I think we have to do is do it like that. Anyways, I could keep on going, but this is clearly a problem here because now we need to like start passing these all around, and that's gonna make it really, really difficult. So using an ECS system where we don't have this entire like struct and trying to sort of force a object-oriented approach is going to be much better for something like this, at least in Rust. So I'm not even going to try to implement the rest of these. It's just going to get nasty. Design decisions. As you can see, Subclass Sandbox is a fairly soft pattern. It describes a basic idea, but it doesn't have a lot of detailed mechanics. That means you can be making some interesting choices each time you apply it. Here are some questions to consider. What operations should be provided? This is the biggest question. It deeply affects how this pattern feels and how it works. At the minimal end of the spectrum, the base class doesn't provide any operations. It just has a sandbox method. To implement it, you have to call into systems outside of the base class. If you take that angle, it's probably not even fair to say that you're using this pattern. On the other end of the spectrum, the base class provides every operation that a subclass may need. Subclasses are only coupled to the base class and don't call into any outside systems whatsoever. Concretely, this means each source file for a subclass would only need a single include for the one for its base class. Between these 2 points, there's a wide middle ground where some operations are provided by the base class and others are accessed directly from the outside system that defines it. The more operations you provide, the less coupled subclasses are to outside systems. The more coupled the base class is, it removes coupling from the derived classes, but it does so by pushing that up to the base class itself. That's a win if you have a bunch of derived classes that were all coupled to some outside system. By moving the coupling up into a provided operation, you've centralized it into one place, the base class. But the more you do this, the bigger and harder to maintain that one class becomes. So where should you draw the line? Here are a few rules of thumb. If a provided operation is only used by one or a few subclasses, you don't get a lot of bang for your buck. You're adding complexity to the base class, which affects everyone, but only a couple of classes benefit. This may be worth it to make the operation consistent with other provided operations, or it may be simpler and cleaner to let those special case subclasses call out to the external systems directly. I do not agree. There's this theory of like broken windows. Once you start adding in like you break the window because we only need this one time, it's not that big of a deal, let's just do it this one time, it'll make it super easy, we'll get this feature done right away, and then we can move on to other stuff. You just broke the window. Now another class comes along, another developer sees that you've done this, you've just opened the gateway for them to do this too. And now they're going to do this. And now suddenly every single addition will now take this pattern. Not the original pattern that you're trying to hope that they followed, this broken window pattern. They're going to just pick up rocks and keep on breaking all the windows because we started with it. It's much easier to argue that you shouldn't do this if you keep yourself, like if you're going to follow the pattern, follow the pattern. When you call a method into some other corner of the game, it's less intrusive if that method doesn't modify any state. It still creates a coupling, but it's a safe coupling because it doesn't break anything in the game. Safe is in quotes here because technically, even just accessing data can cause problems. If your game is multi-threaded, you could read something at the same time that it's being modified. If you aren't careful, you could end up with bogus data. Unless you're using Rust. Another nasty case is if your game state is strictly deterministic, which many online games are in order to keep players in sync. If you access something outside of the set of synchronized game state, you can cause incredibly painful non-determinism bugs. Yeah, absolutely. Like that's big problems if you're running on a multi-threaded system and you're not using a safe language like Rust. Now, Rust, as we see, doesn't allow us to program in such a way that would get us ourselves into that state to begin with. So we have to come up with a completely different paradigm of programming because of that. Chantilly, good morning. Hello. Calls that do modify state, on the other hand, more deeply tie you to those parts of the codebase, and you need to be much more cognizant of that. That makes them good candidates for being rolled up into provided operations in the more visible base class. If the implementation of a provided operation only forwards a call to some outside system, then it isn't adding much value. In that case, it may be simpler to call the outside method directly. However, even simple forwarding can still be useful. Those methods often access state that the base class doesn't want to directly expose to subclasses. For example, let's say Superpower provided this. Okay, so we have a playSound method, taking the sound ID and the volume, and then soundengine.play sound volume. It's just forwarding the call to some sound engine field in Superpower. The advantage, though, is that it keeps the field encapsulated in Superpower so subclass can't poke at it. And this is sort of what I was imagining. We're kind of, because this is kind of what I'm thinking of doing here. Is it doesn't like reach in, it calls in and like does that. Now, even better yet, if Sound Engine passes play into Superpower. So, for example, this is going to be a lot easier in JavaScript here. But if I had a constructor here, and I take in like play sound, this dot obviously won't like maybe we should know like this dot sound engine. How about that? This dot sound engine equals sound engine. If we do this, then in play sound, under play sound, we can do this dot sound engine dot play, pass in sound ID and the volume. The key to this is that we've injected in the dependency of Sound Engine into Superpower, and this changes the entire dynamic around, because now Sound Engine can change. And it's fine. We can even create like a version 2 of the Sound Engine and pass it into Superpower just to see what happens and like go back to the original one if necessary. Should methods be provided directly or through objects that contain them? The challenge with this pattern is that you can end up with a painfully large number of methods crammed into your base class. You can mitigate that by moving some of those methods over to the other classes. The provided operations in a base class then just return one of those objects. For example, to let a power play sound, we could add these directly to Superpower. Okay, so in Superpower we have play sound, stop sound, set volume. But if Superpower is already getting large and unwieldy, we might want to avoid that. Instead, we create a sound player class that exposes that functionality, which is sort of what I'm expecting with this like Sound Engine is an instance of the sound player. Okay, so we have our sound player, play sound, stop sound, set volume. Then Superpower provides access to it. Right, so it's basically oh, interesting. This one is get sound player. Okay, so this is slightly different than this one here. So if I comment this out, then we wouldn't have like play sound like this. We would have something like get sound player, which returns like a sound player. If it's like just has static methods on it, we could just return sound player, the class itself, or an instance of the class. So if we have some kind of like set up internal state, we can have like the global state dot sound player, something like that. This would work for that. Shunting provided operations into auxiliary classes like this can do a few things for you. It reduces the number of methods in a base class. In the example here, we went from 3 methods to just a single getter. Code in the helper class is usually easier to maintain. Core base classes like Superpower, despite our best intentions, tend to be tricky to change since so much depends on them. By moving functionality over to a less coupled secondary class, we make the code easier to poke at without breaking things. It lowers the coupling between the base class and the other subsystems. When PlaySound, other systems, not subsystems. When PlaySound was a method directly on Superpower, our base class was directly tied to Sound ID and with whatever audio code the implementation called into. Moving that over to Sound Player reduces Superpower's coupling to the single Sound Player class, which then encapsulates all of its other dependencies. How does the base class get the state that it needs? Your base class will often need some data that it wants to encapsulate and keep hidden from its subclasses. In our first example, the Superpower class provided a spawn particles method. If the implementation of that needs some particle system object, how would it get done? Pass it to the base class constructor. The simplest solution is to have the base class take it as a constructor argument. So then we can have, so here's the constructor, the particles is like the particle system, and now we're just storing that. And now it's, so this is like the dependency injection side of things now. This safely ensures that every superpower does have a particle system by the time it's constructed. But let's look at a derived class. So Skylaunch, and now it's taking particles. And so it can like just call them directly. Here we see the problem. Every derived class will need to have a constructor that calls the base class one and passes along the argument. Oh, right, because it needs to call super and pass in and pass that in. And I think that's because Superpower is never going to be constructed itself. So therefore, its constructor will only be called by the child in this specific example. Here we see the problem. Every derived class will need to have a constructor that calls the base class one and passes along the argument. That exposes every derived class to a piece of state that we don't want them to know about. This is also a maintenance headache. If we later add another piece of state to the base class, every constructor in each of our derived classes will have to be modified to pass it along. Do two-stage initialization. To avoid passing everything through the constructor, we can split initialization into 2 steps. The constructor will take no parameters and just create the object. Then we call a separate method defined directly in the base class to pass in the rest of the data that it needs. Superpower, so we have a power that's type Superpower. We create a Skylaunch, and then we have to init it and pass in particles. That's still, I don't know, it feels like it's moving, it's just moving it from here to here. Note here that since we aren't passing anything into constructor for the Skylaunch, it isn't coupled to anything we want to keep private in Superpower. The trouble with this approach, however, is that you have to make sure that you always remember to call init. If you ever forget, you'll have a power that's in some twilight half-created state and won't work. You can fix that by encapsulating the entire process into a single function, like so. So create Skylaunch. So now we have like the builder method where we can like build a superpower and then pass in like whatever we need for that specific power, which then does all the things. With a little trickery like private constructors and friend classes, you can ensure this create Skylaunch function is the only function that can actually create powers. That way you can't forget any of the initialization stages. Make the state static. In the previous example, we were initializing each superpower instance with a particle system. That makes sense when every power needs its own unique state. But let's say that the particle system is a singleton and every power will be sharing the same state. In that case, we can make the state private to the base class and also make it static. The game will still have to make sure that it initializes the state, but it only has to initialize the Superpower class once for the entire game and not each instance. Keep in mind that this still has many of the problems of a singleton. You've got some state shared between lots and lots of objects, all of the Superpower instances. The particle system is encapsulated, so it isn't globally visible, which is good, but it can still make reasoning about powers harder because they can all poke at the same object. Okay, so we have class Superpower. When we have this init method that takes in the particles and stores that away. So, we're injecting the particle system in, and then we're just storing that in here. Note here that init and particles are both static. So static, right. Init has to be called on Superpower itself, not like not a piece of like Superpower, which is interesting here. As long as the game calls Superpower init once early on, every power can access the particle system. At the same time, Superpower instances can be created freely by calling the right derived class's constructor. Even better, now that particles is a static variable, we don't have to store it for each instance of Superpower, so we made the class use less memory. Use a service locator. The previous option requires that outside code specifically remembers to push in the state that the base class needs before it needs it. That places the burden of initialization on the surrounding code. Another option is to let the base class handle it by pulling in the state that it needs. One way to do that is by using the service locator pattern. Okay, so we have class Superpower, protected spawn particles, particle type. Okay, so we have spawn particles here, and it runs this. Okay, so static method off of the locator class to get the particle system, which then it can call on. So that this means you have some kind of class that holds like the other classes or can grab them. So locator sounds like it would be a facade that just has like these methods to go grab them from wherever they are elsewhere in the entire architecture. Here, spawn particles needs a particle system. Instead of being given one by outside code, it fetches one itself from the service locator. See also, when you apply the update pattern, your update method will often also be a sandbox method. This pattern is a role reversal of the template method pattern. In both patterns, you implement a method using a set of primitive operations. With Subclass Sandbox, the method is in the derived class, and the primitive operations are in the base class with template method. The base class has the method, and the primitive operations are implemented by the derived class. You can also consider this a variation on the facade pattern. That pattern hides a number of different systems behind a single simplified API. With Subclass Sandbox, the base class acts as a facade that hides the entire game engine from the subclasses. So yeah, that's what I was talking about, is like the facade might actually help out with this. Now, something that I just thought of would work with Rust maybe a little bit better is to use some kind of channel or observer pattern with this. So let's say we have an independent Skylotch superpower here. Then when we're called, when we run this activate on it, instead of passing in all of these different things, so let's like maybe create like a different trait for this. So trait real superpower. Here we're gonna have a function activate, which maybe just has self. the real like big thing here is that we want to now notify, like notify all the observers. So we have like some kind of observer system that's gonna be passed in that then we need to notify, hey, something happened. So maybe here we pass in the event system. So the event system, and this is going to be a mutable reference to the event system. Now we don't override this. What this does mean for us is that we don't need, let's now implement this down here. So implement real superpower for Sky Launch. Here we have activate. We have our self and our event system here. When we want to now activate, we want to say, we can do all of our like, sort of like gets and everything else that we need. What we want to do for like the simple jump here is tell the event system that we want to like jump the hero. And maybe this works, maybe it doesn't. Like maybe I'm overcomplicating it. I'm not sure. I'd have to actually like try to implement this for real in an actual game to sort of like see how this works. I still feel that going with an ECS system, and then maybe like dropping in and having like a queue of these might be better. That would probably help out a lot. But if I did this, now I can do an event system dot like notify. And then we'll have to have some kind of enum. So enum events, and maybe our events could be, we could have like jump, and then the amount, which is an F32. Maybe we can also have things like sky jump, which is also an F32, and like dive. So if we have all of these, maybe we don't even define them. Maybe we just say like, here's what these are. We have jump, skydive, sky jump, and dive. And so now maybe we do need the hero, but maybe like off of here of real superpower, we're gonna have to have like the getters for, okay, so function get hero Y, let's say. So self, do I want to like override this and like somehow get the hero system? See, I don't know. It breaks down when we need to get more information. So I still don't. Yeah, even looking into this, I think we run into this problem. It's just not something that we want to do in Rust. It works really well with object-oriented languages, but Rust is not an object-oriented language. At least not with something that has subclassing behavior. And that's kind of what we're trying to do here. And we end up having to like fight Rust's compiler system and borrow system in order to like get this working. Because I still need to get like the hero itself to pass that in, which is not really helpful to us, because then we run right back into the same problem here. And maybe I can only pass in like the hero. Maybe that will be fine. But that means everyone that runs activate will need to pass in the hero, even if they don't need the hero. And that's the problem. We're tying ourselves into a specific system. So yeah, I don't know. I thought of it as an idea, and I don't think it's a good idea. So I'm gonna delete that. Okay, so I'm gonna save you. We've reached the end of our chapter here. Let's go ahead and open up Get Kraken. I realized that I actually had started a branch a few days ago, and I've been accidentally committing these changes to it. So I'm going to go back to master for at least this one. Oh, 2 conflicts. No. Okay, so that's. Well, I'll have to play around with that. Let's go ahead and. Oh, I have bytecode in here too. What kind of changes did I do in master for this? If I stash, let's go back to master. And now let's pop this out and see what we've got. Conflicted. Oh, we have bytecode. Has modified one branch and deleted on the other. I want to. Which one is it modified on? Is it modified? Which one's modified and which one's not? What's base and what's playgrounds? Backup has been modified on one branch but deleted on the other. I want to keep the modified version. Okay, and then now let's see. So we just did a subclass Sandbox pattern, and I'll push that up. We have access to all this code with the bang repo command, or in the video description. I'm going to have it in the description for that, so you can go sort of take a look. Feel free to do pull requests or anything else if you like want to add in code, or you just want to add an issue to say ask questions about it. And with that, I'm going to go ahead and get ready for the rest of my day. So let's go ahead, reactivate you, and switch over to the ending screen. Thank you everybody so much for stopping by and watching me learn this subclass pattern. It's a very interesting pattern, but not necessarily one that I think that I'm going to be doing too much with. We're going to be going tomorrow into what's tomorrow's pattern? Tomorrow's pattern is going to be type object, which is going to be the last pattern of the behavioral patterns. And I'll be here at 7 a.m. Mountain Time to around 8:15 or so. I've been doing these every single weekday at 7 a.m. Mountain Time. And so with that, have a great rest of your day, and I shall see you next time.